In the previous chapter, we have studied the concept of inline function. Let us study the same concept along with classes and object. This is the modified version of the previous program. Sum is a member function of the class Sam. This member function is defined inside the class Sam, and that is why the C++ compiler will treat this function as an inline member function. What is the condition for inline function? The code of the function sum should be small. Only in that case the C++ compiler will treat it as an inline function. I'll repeat this sentence. You see, the function sum is defined inside the class and it's a small function. That is why C++ compiler will treat it as an inline function. Is it clear? Well, observe the next step. The function initialize and display, these are the member function of the class Sam. These functions are declared inside the class Sam, but we have not defined this function inside the class Sam. We have defined these two functions outside the class, and that is why these are not inline member function. If you want to convert the function initialize into an inline function, then use the keyword inline. So after using this keyword inline, the initialize member function will behave as inline member function of the class Sam. Observe this statement. Here we have not used the keyword inline, and hence display is non-inline function. What I said? The function display, member function display, is defined outside the class and we have not used inline keyword, and that is why this function, this member function, is not an inline function. Is it clear? I'll show the diagram again. This function is outside the class, but we have used inline keyword, and that is why it is an inline function. Whereas display we have defined outside the class, we have not used inline keyword, and that is why this is not an inline function. Is it clear? Well, now observe one more interesting point. In this program, I declare one more independent function, namely display. This is a member function display, while this is a independent function. We'll say that it is a normal function because display is not the member of any class. Is it clear? I have shown this one in this diagram, the second display function over here. This display function is not a member of any class, and that's why we will say that it is a normal function. Is it clear to you? Observe carefully. There are two display functions. This display function is the member of the class Sam, while this display function is the normal function. Now the question is how to distinguish between normal function and member function, which is defined outside the class. In C++, there is a special facility to define a function outside the class, and that's why C++ compiler can distinguish these member functions. You observe very carefully how I define the function initialize. You see, the syntax is return type. So return type of the function initialize is void. Then after that I have mentioned the name of the class. So Sam is the name of the class. Then resolution operator. After that, name of the function, that is initialize, and then list of arguments. Is it clear? So using this syntax, if we define the function, then C++ compiler can identify that initialize is a member function of the class Sam. Its arguments are integer type. There are two integer type of arguments, and its return value is void type. Is it clear? Observe carefully the declaration of the function normal function display. It's a normal declaration of the function. And that is why for a compiler it is possible to distinguish between these two display functions. You observe it. Here display is a member function of the class SAM. It has no argument and return type is void. While this display function, it is a normal display function with two arguments. Both are integer type and return type is integer. Is it clear to you? Let us execute the program up to this step by pressing F4 key and observe carefully. We are calling a public member function initialize from the function main, and that is why we have used the name of the object k and dot operator. Press F7 key. Inside the function initialize, we are accessing data members A and B. So through member function, we are accessing data members, and that is why k.a and k.b it is not needed. Directly we can use A and B to access the data members. Is it clear? Execute the program. Let's see the function display, how we are calling it. We are calling public member function display from the function main, and that is why we have used name of the object k and dot operator to call this function. Press F7 key. Here again observe one important point. Display is the public member function of the class, namely SAM. Sum is also a private member function of the class SAM. So we are calling a member function from another member function, and that is why we have not used k.sum. That is, neither we have used name of the object nor we have used dot operator. Execute it. Press F7 key. Here again inside the function sum, we have directly used A and B. We have not mentioned k.a and k.b because sum is a member function of the class SAM, and that is why we should not use dot operator for accessing A and B. Is it clear? Execute it. And at last display the result. Press F8 key. What is the output? 300 is displayed. Here we are calling the normal function display, for which the dot operator as well as the object is not needed because it's an independent function or it's a normal function. Is it clear? To this function we have passed the arguments 10 and k.b. In the k.b, b is the public data member of the class SAM, and hence we can access it through the function display. Execute it. Press F7 key. Which values are passed to this function? A value 10 and content of k.b. It will be assigned to the parameter A and B respectively. So content of A will be 10 and content of B will be 200. So return value will be 200 multiplied by 10, that is 2000. Execute and see the output at DOS prompt. 2000 is displayed. Is it clear to you?